Okay, I'm back, and now we want to talk about what are some features that are going to be formed by lava. So the first one is that the lava can, again, just basically erupt out of the ground as a nice fountain, or it could erupt and basically just go sideways. And so we're going to call these things fissure eruptions. So they erupt from a fissure, a linear crack in the ground where this material comes up. So it tends to make fountains, and it also tends to run sideways on the ground and make these flood basalts. Now, the flood basalts are normally limited in how large that they are. However, you can also have very large flood basalts, which we're going to call large igneous provinces, which is abbreviated by LIP. These things can cover hundreds of square kilometers. So if you go up to Washington State, you will find that a lot of that state is covered in these large igneous provinces. And we think that these large igneous provinces are a result of a hot spot that is underneath the ground. So if you recall, we talked about that in the Pacific Northwest, you have Yellowstone National Park, where there is a hot spot underneath it. And so when that erupts, it produces a lot of these flood basalts. Okay, so next let's talk about volcanoes. So in this picture, you see three different kinds of volcanoes. You see the cinder volcano, or cinder cone, and it is the smallest and it is the most numerous of the different kinds of volcanoes. You can barely see it in that picture. So it is very small, and it is going to be composed of pieces of scoria. So we could also call these things scoria cones. So scoria is this mafic material that has gas holes in it, and it comes out of these cinder cones and it piles up around it. And so you generally don't get a whole lot of lava coming out with it. So it's just a bunch of cinders, scoria, that is spraying out of the volcano, and it collects around the outside of it. Okay, then you've got the shield volcanoes, which that's the big one there at the top. So you can see that it's named a shield volcano because it's very flat, and it kind of looks like a shield. So the volcanoes of the Hawaiian Islands are all shield volcanoes. They're going to be produced by very mafic magmas. So mafic magmas, the ones that are the most runny, are the ones that are going to produce the shield volcanoes. Because when this material comes up, it's so runny, it basically just goes sideways. It doesn't build up. So there's your shield volcanoes. Now you can also have shield volcanoes on continents. So if the magma makes its way up to the surface and does not change its composition, so if you recall, it starts out being mafic when it's in the asthenosphere, and then as it comes to the surface, sometimes it becomes more felsic. So if it comes to the surface without altering its composition, then it's going to ooze out onto the surface as a shield volcano. These have the gentlest explosions. So when a shield volcano goes off, it's a pretty gentle explosion, and you don't really need to run away from it, as opposed to the stratovolcanoes. So these are going to be composed of andesitic and felsic lavas, which are going to have a lot of silica in them, which means that they're very viscous, which means that they tend to clog up the volcano. and then pressure builds until the eruption explodes the volcano. So that these stratovolcanoes are the most explosive of the volcanic eruptions, and it's because that they consist of a lava that is the most viscous. And so examples of these would be Mount St. Helens and Mount Shasta in the Pacific Northwest. Okay, another thing that you can have is a volcanic dome. So that when a stratovolcano erupts and it shoots out all of its material, the pipe that is supplying the material to the volcano tends to get clogged up because the lava is very viscous. And so once it gets clogged up, then the entrance to the volcano starts to bow up because there's material underneath it, and that's what's making these volcanic domes. Very viscous material is creating this dome inside of the volcano. So this is how we know that a volcano might be getting ready to erupt. Whenever you see the ground starting to bow up like this, that must mean that there's stuff underneath it coming up. Then you also have the remnants of the volcano. So the material that was in the pipe that was leading up to the surface, so sometimes that material will completely harden up. The material that is surrounding the pipe is going to be composed of pyroclastic debris that is less resistant to rain and snow and wind and ice. And so that stuff, the original volcano, can be eroded away, and then what's left is the interior of the volcano, which we call the volcanic neck or the volcanic stalk. And then you can also have calderas. So what can happen is, as long as the magma chamber that is feeding the volcano is full of magma, it can support the weight of the volcano. However, if once the volcano uses up its magma and then the magma chamber starts to drain, then it can no longer support the weight of the volcano and it's going to collapse, and then what you're going to be left with is this caldera, which can fill up with water and then it can turn into a lake. Now, I want you to remember this process because later, in a later lesson, we're going to talk about karst topography and how you can have limestone, and under the ground in the limestone can be water. And then that water can form caves. And so as long as that cave is full of water, it's going to support the roof of the cave. But then when the water drains, what can happen is the weight of all the ground on top of it can cause it to collapse, and then we're going to call that a sinkhole. So notice that the sinkhole is to karst topography what the caldera is to volcanic topography. Okay, we're going to take a break, and when we come back, we're going to talk about where do you find volcanoes.